Okay, thank you for joining today's webinar, File Upload Security for BFSI, Lessons Learned. My name is Russ Schofield. I'm the RSM for BFSI across Northern Europe. And Ross, who's also joined the call, is my technical counterpart. We're making the link available after today's short session, so if you want to share that amongst all the registrants or other employees within your organisation, that'd be great. If any of the content resonates or the internal projects meet with what we're presenting today, then please reach out to either myself or Ross. After the call, we'll be happy to set up a follow-up session and do a more technical deep dive. I'd like to keep this session interactive, so please shoot any commercial questions into the chat box. Ross and I will circle back at the end of the presentation, do our best to answer those questions. But before we jump into the actual content of this webinar, I think it's really important to stress that both Ross and I, we spend every working day dealing with global financial organisations. We know the issue of malicious file upload is incredibly real across BFSI. In the last year alone, Ross and I, we've delivered about 9 projects to global banks. And what we've helped them to achieve is the desired security posture, meet the required compliance, and help them to align with internal audits. But before we go into the product and more about how we do this, I think it's very important to stress that tech doesn't need to be complicated. It simply needs to work. In cyber, I think the philosophy is it needs to either detect or prevent. And I think in the case of OpSWAT, we do both. We're really good at both of those. For absolute clarity, OpSWAT are the best in the world at both detecting and preventing malicious file upload. We prevent it from crossing the security boundary, full stop. Banks and FSI partner with OpSWAT because we deliver a solution that works. I'm just briefly going to tell you about OpSWAT and why we're here, where we've come from, what we're doing around the world. OpSWAT have been protecting the world's critical infrastructure for over 20 years. We protect some key industries such as nuclear, oil and gas, utilities, transport, government, manufacturing, and very importantly, MOD. We are trusted by the most critical organisations on the planet to ensure that the world functions as it should do without fear of a cyber attack or a cyber breach. Excuse me. For the purpose of this webinar, we're going to focus on financial services, which, as we all know, is part of the global critical infrastructure. What's very unique about the BFSI use case is that we pretty much see the same problems in every organisation that we work with. It's always the same use case. It's file upload security. It's always the same use case, but typically it's a different delivery method or deployment model. But I'm going to make a very bold statement lead and a marker for the rest of this webinar. OpSWAT are absolutely amazing at scanning files. OpSWAT are amazing at sanitizing files. And more importantly, OpSWAT are amazing at analyzing files. We are the best in the world at file upload security. That is a really bold statement. If you look at the work that Ross and I have done with financial services over the last year or so, when we typically talk to a customer and we present the technology, we typically win that deal. I mean, fundamentally, when you have a technology that can deliver detection, prevention, analysis, you've got a game-changing technology. And I think when you deliver these as part of an automated process or an automated platform, you have a technology that really changes the game. There is no competition out there for OpSWAT. It's a massive plus that we can deliver analyzing files, detection, and prevention. So listen, we're going to go on to the problem statement now. So this is why we're here today. We're talking about BFSI. Why are global banks, global insurers, and global payment processors turning to OpSWAT in droves? We are seeing massive traction in financial services. Let me just tell you, usually when Ross and I walk into a meeting at C-level, we get asked typically 3 questions. Can OpSWAT ensure that only clean files enter the network? Absolutely, it's what we do. Next question, can you deliver clean files into the network without impact on the user experience? 100%, that's what we do. And the final question is typically, can OpSWAT process the millions of files that we're receiving every day without impacting performance? Yep, that's what OpSWAT was born to do. So there are the 3 key requirements when we walk into larger enterprise deals, BFSI organizations. So why is all of this current in the sector at the moment? Why is BFSI, turning to OpSWAT? The simple reason is we're seeing a massive explosion in public-facing application development. This is the way that banks, insurers, they communicate with their employees, their customers, and their business partners. Banks and insurers are in a race to digitalize all services. As more applications launch, the more the attack vector opens. The more you open your network to the public, the higher the chance of a cyber attack, particularly with file upload. This can be state-sponsored attacks. It could be a financial cyber attack. It could be, just a pure error on one of your users' behalf. They could accidentally upload a malicious file to your network. But ultimately, you've got to make sure that the files are entering the network are clean. So when we talk about file protection, we also talk about perimeter defense. We don't talk about EDR. EDR is a very different use case to what we do at OpSWAT. We have a mentality of not allowing any malicious files to cross the security boundary. There's many reasons for this, but we'll go into that in more detail when we present some of the technical slides. There are thousands of endpoints out there that are open to misconfiguration. You've got thousands of endpoints. If you let malicious files into your network where dormant files can sit there and maybe attack later, there can be lateral movement across the network. And ultimately, why do you want all of these malicious files triggering security alerts inside your network? Why not just block them at the perimeter? Next slide. So typically, when we look at the data flow into an organization, when we talk to BFSI customers, it's predominantly file upload. You've also got email, you can have endpoint, you can have peripheral media, you can have third-party hosted solutions, for example, Salesforce, bringing those files into your organization. And typically, we tend to rely on endpoint for this. We don't rely on sort of perimeter defense. We've spoken to many insurance companies where the only perimeter defense they've got is a single AV at the perimeter. And in many cases, this can actually be open source. And when we talk about open source antivirus, if I were to develop a new variant of malware, the place I'm going to test that is with open source antivirus vendors. So the likes of ClamAV, they're not sufficient as a standalone product at the perimeter. So what OpSWAT do is layer multiple products on top of each other to ensure that you get the highest efficacy rate when files are uploaded to your network. I've said this before. I'm confident in this assumption. I'm confident in this statement. We are the best in the world at what we do. We're now going to give you a very, very brief platform overview. Please challenge me on that statement. I'm making a very bold statement. We're the best in the world at preventing malicious file uploads. Challenge me on that. I'll be quite happy to answer any questions. I'm just going to pass over very briefly to my colleague Ross Moore, who's just going to take you through a very quick product overview. Thanks.
Great, thanks Russ. So let me take you through 3 key features in our MetaDefender platform for securing file uploads in financial services and insurance. So the first capability here is multi-scanning. So with OpSWAT, we don't use one antivirus engine. We can scan files with over 30 of the world's best antivirus engines in parallel to detect nearly 100% of threats. So you might ask, well, why do I need over 30 antivirus engines for file scanning? I thought most AV vendors give 99+% detection anyway. Well, as you can see here, when you're deploying AV engines in a perimeter scanning use case, the engines are actually much less effective at detecting malware than when running on an endpoint, such as a typical user desktop or laptop. You'll typically see maybe 95 to 99% detection rates when running these engines on an endpoint, but when you deploy the same AV engines in a perimeter use case, their effectiveness drops significantly, right down in some cases to less than 50%. So the detection rates you see here on screen are a result of OpSWAT testing against the top 10,000 malware threats currently out there in the wild with the shown AV packages that we can provide. Now, with financial customers, we typically look at a minimum of a 95% detection rate. So the 16 AV engine package shown is generally a starting point for multi-scanning within financials and insurance companies. But as you increase that number of engines, maybe to 20 AVs or 33 AVs, which is in our max engine package, you can run all the way up to nearly 100% detection rates with that max engine package.
I guess, Ross, an important question, if I may, before you just jump on to the next slide. Look, we've seen all those packages, you've got the max engines, the 16, the 8. By layering more and more AVs on top of each other, are you not ruining the performance? Is it taking a lot longer to scan the files? Are we seeing a degradation in performance? What typically are we seeing when we layer more and more AVs on top of each other?
Great question. Yes, good call, Russ. So with performance, particularly if you have a real-time file upload use case where maybe an end user, a customer, is waiting for confirmation that a file was actually successfully uploaded, scanned, and approved for use, with our multi-scanning framework, we ensure that all the AV engines are scaled to have effectively a CPU core per engine. So what you see is this ensures file scanning running in parallel in all situations, and still provides rapid responses back to application portals to confirm whether a file is clean or not for user confirmation. So we maintain that performance of the platform with additional AV engines by making sure we upsize the resources supporting those engines and making sure there is always sufficient CPU capacity for the scanning operations to take place. And that's a very common use case for us. Yes, that sort of real-time scanning upload into file upload platforms.
Okay, just to clarify that, Ross. So what you're saying is we're running as slow as our slowest AV, not sequential scanning.
Exactly, that's right. So whatever the slowest AV engine will be the slowest rate that we can scan a file through the platform. Because the slowest engine is the one that will dictate that throughput effectively.
Would you have the ability to remove that engine, Ross, if that was really slowing down performance? Could you swap that out for another engine potentially?
You can, and there are all sorts of configurations you can do to configure how many parallel threads that engine has available to it. We also provide a level of reporting around the engine performances, so you can fully see how your engines are performing against different file types as well, as different engines do support different file types in different ways. And I can cover that off. I think I have a screenshot in a couple of slides that will illustrate that quite nicely.
Okay, thanks, Ross.
Okay, so also it's worth noting that we use a large geographic dispersion of AV vendors built into the multi-scanning packages as well. So what are the advantages? Why do we do this? Well, when you have malware outbreaks, the AV vendors closest to those outbreaks often detect the outbreak first and will immediately update their engine signatures to identify and block those threats. So by combining lots of different AV vendors into our multi-scanning packages, this actually enhances and enables faster detection of new malware outbreaks as they are released and triggered. And yeah, here, as you can see from this screenshot, one of the very interesting aspects raised when testing and running our platform in customer environments, often during evaluations, customers are often surprised at how different antivirus engines do, and more importantly, don't detect malware. So as you can see here, as files are scanned through the different AV engines within our platform, only some of those engines are flagging files as containing malicious content. Now, for some engines, for example, those maybe that use AI to detect malware, these are trained with specific file types. So they can be very good at detecting, say, malware within documents. It could be PDFs, Word documents, Excel files, etc. But if the same AV engine is used to scan maybe software executables or firmware updates, then their detection rate can drop massively. And this is where it's great to have a multi-scanning approach with your AV engines, because the more coverage you've got with different engine capabilities, the better your overall detection rate.
Ross, that's a great point. So listen, we understand we use heuristics, we use signature-based, we use AI, we use ML. So we use a fully layered approach to detection, which is great. So I think it'd be really good just for you, just for 20 seconds to explain. We did a recent POC with a major global bank, and it was a really interesting finding. I know it was a massive file. It was 50 archives. Just talk the guys through that actual story, please.
Sure, yes, yeah. As one of the examples recently in testing, a bank was testing a very large archive file. We're talking 48 to 50 gigs worth in size. Now, this archive file was basically zipped up 50 layers deep. So the source group of files was actually 1.2 million files with a small component of malware embedded and hidden, tucked into those 1.2 million files. And then what they did was they zipped that bank of files, that group of files, 50 layers deep. So they zipped it and zipped it and zipped it and zipped it, 50 layers deep, and then provided the archive file into us to see if we could detect the malware tucked away in there. And OpSwap was great. We were very successful at unarchiving all of the different 50 layers right down to the component 1.2 million files and detecting that small piece of malware. So really, as long as the underlying platform, you provide enough disk space for us to do the archive extraction, then absolutely, we will work through even massive archives to detect small components of malware hidden, nested in these huge potential file archives. So yeah, OpSwap is great for use. It doesn't matter whether you're just looking at small scale, it could be high volume, small size document files, or it could be larger ISOs, CAB files, software updates, maybe containers, things like that. We have a great use case across all sorts of different file types for detecting malware.
You're seeing, sorry, Ross, you're seeing the large files and the high volume files. How are you configuring that? Are they on different clusters? Would it be on the same cluster? Just talk us through that, please.
Absolutely, yeah. So within OpsWatt, what you can do is you configure workflows, and you can specify when you upload a file into OpsWatt, which workflow you want that file to go through. And we can create priorities for different workflows. We can specify sort of different file types to be taken in. We can specify how many AV engines you should be running the file through. So there's a whole range of configuration that you can provide for different file scanning services. So a common use case for OpsWatt is actually configuring a bank, basically a pool of OpsWatt servers, and then files are uploaded using different workflows to support different service requirements. So it could be just detection with the multi-scanning engines. It could be what we're about to move into more on the prevention side with file sanitization. That's another option that you could use the same set of servers for and just configure a different workflow that those files are run through. So it's a very flexible configuration you can deploy into the system to manage different requirements that you have within the business for cleansing, detecting, and preventing malware from coming into your environment. Great, so yeah, I think that's probably a good point to move on to the actual next component, which we talked about detection there, detecting threats that have been seen before. But what happens if maybe you have brand new malware? It could be zero-day threats that have never been seen before, which can bypass AV engines without detection because they've simply never been seen before. It's a brand new type of malware. What do you do then? Well, this is where we would recommend using our Deep CDR capability for malware prevention. So Deep CDR stands for Deep Content Disarm and Reconstruction. Essentially, this is a file sanitization capability. And what we do here is we sanitize a file contents so that you can still use the data from the file, but effectively in a rebuilt known safe copy of that file. So say for instance, as an example, if you have members of the public and they want to be applying, they've got mortgage applications, they're applying for a new mortgage, but their home PC or their home laptop is compromised. It has some sort of malware on it, and that is infecting all of the files that they're sending out. Now, you as a bank still want to be able to receive and process their mortgage application because there is probably a time-sensitive nature to them getting a mortgage approval. And you would need to use that data, but make sure that it is, first of all, safe to use within your organization. So with Deep CDR, we can actually take over 160 different file types into our platform, analyze and rebuild those files in a known safe format, enabling you to use the safe copy of that file, while the original file, which may have the malware in it, that is then discarded, or it can be quarantined if you still want to maybe run it through a sandbox at a later date. So to go into a little bit of further detail here, just as a visual example, here on the left-hand side, you can see an example of a source file that could contain potentially malware. It's got lots of different objects in it, such as text paragraphs. It could have embedded images and videos. You could have macros, for example, in an Excel document, or you could have hyperlinks going out to the internet. You could also have active content embedded in there, like JavaScript, ActiveX, maybe Visual Basic code as well within the file. So what we do with CDR is we recursively break down the file into its constituent objects, and then we rebuild those objects based on a safe file configuration. And this is all configurable within MetaDefender Core itself. So you can state how you want to sanitize the file. So we could remove macros that could be harmful. We can recompress images and maybe remove or maintain the metadata if you still need things like GPS location information that can be embedded in those files. We can remove hyperlinks that could potentially be phishing attempts. And then what we do is rebuild all of those objects into the top level container file in a now safe copied content that is safe for you to use within your environment. So if you think of, for example, the airport security analogy, just to relate it to this, when you go to the airport and you're having your bag scanned, then the X-ray machine is the equivalent of your antivirus engines. They are looking for known shapes of objects within your bags to make sure that there is nothing harmful or dangerous crossing your security perimeters that shouldn't be permitted. With CDR, what we're doing is after the AV scanning, we're taking your suitcase, we're unpacking it, and then we're repacking it into a known standardized baggage type. So we know that there aren't any hidden compartments or capabilities that shouldn't be in there.
Ross, quick question. Just on the Deep CDR and the multi-scanning, is this asynchronous or is it synchronous, or is it an option for both?
Sure, so you can configure that within the platform. So you can choose whether to run, if you know you're going to run a file through CDR, then maybe you run it through fewer AV engines for that initial detection and visibility of maybe if there are malware threats in there. And then you can use the CDR engine to ensure that the actual content of the file, essentially the data that you really need, it could be identity information, maybe know your customer information, is something that you can use to move forward with whatever business reasons you need to use that data for.
Okay.
Great. Yeah. So that covers malware detection with multi-scanning. And we've also covered malware prevention with deep CDR. So the next and third capability that we want to talk about that's embedded into the MetaDefender platform is our adaptive sandbox. So for malware analysis, we have our next generation adaptive sandbox, which is very useful for low-level analysis of files to give a better understanding of the implications of what would happen if that file was opened or executed within your environment. And we call this a next generation sandbox because it doesn't use virtual machines for analysis like a lot of other traditional sandboxes. We instead use emulation. Now, why do we use emulation? Well, typically, malware nowadays is always designed to evade detection by using a variety of techniques. It could be identifying the type of host that the malware is running on. It could be looking to see, is this a physical laptop or desktop? Or is it, if it's running on a VM, that could indicate that this is actually a sandbox environment. Also, it can look to check versions of maybe your operating system or your software application if someone is targeting your environment and they know the types of applications you use. Or it could be operating as latent malware. It could have some sort of sleep statements or delays in there that only cause it to trigger after maybe a few weeks or months of being latent within your environment. So with a traditional VM-based sandbox, you would have to create a VM with associated operating system and application software to match what the malware is going to trigger in. And then when you launch that file within that environment, you're going to have to associate time and resources effectively to analyze and review what that file is going to do. By using emulation, we understand how the file is opened or executed regardless of the underlying platform, whether it's Windows, Mac, Linux. We understand how that file format is opened and executed in an active environment, which enables us then to rapidly process and analyze the files to produce a detailed forensic report on that file's contents and its potential risk in your environment. And because we're doing this in an emulated environment, not within VMs, we can do this 10 times faster than a traditional VM-based sandbox, and it uses 100 times fewer resources as well. So it's 100 times more resource efficient. So the fact that it runs more quickly and that it uses far fewer resources means you can actually scan more files through the sandbox in the same time frame, making it a more effective solution for running your files through on a regular basis.
Okay, well,
so, sure.
So we've gone through the detection, the multi-scanning. We've gone through the prevention, the CDR. We've gone through the sandbox, which is analysis. Now, different business units, different file types, they can all be configured to, take advantage of the different services. They don't all have to use the same three processors. For example, a PDF could just go through scanning and CDR. That's totally configurable by business unit, by file type.
Absolutely. And you can specify the AV engines. Really, they give you visibility. Are you receiving malware and where are you receiving it from? So, for example, you could regularly be receiving malware from a particular source, and you might then want to review, do you actually allow any files to come in from that source? This is where you can then run those files through the sandbox, and this will give you a great breakdown to understand what the potential threat could be and what's coming from that source, so you can determine whether to block files from that source, or potentially, if they're sending you, maybe it's some sort of custom application that they're trying to send through to you that installs on your machines, and maybe it looks like malware because it's persistent, it's going to install on your operating system and live there for a while and do certain operations. It might be something that actually you've asked them to produce for you. In that case, the sandbox will analyze the content and the capabilities of those files and give you the confidence to know whether you should allow those files through or whether you should block them and look for other sources maybe to run your files with. So yeah, the great thing with the sandbox is it provides a fast forensic analysis of both static and active contents embedded within files. So hyperlinks going out to the internet, we will actually look at things like what is the potential downloaded content from those links, assess that as well, perform dynamic analysis on that active content. And we can also detect and classify threats using a combination of machine learning and threat intelligence integrations. So having the 3 layers of detection, prevention, and also the analysis layer with the sandbox really gives you that confidence to understand how you're ingesting files into your organization and how you're managing them and whether they're safe to take in and use going forwards as well. Great. So all of these capabilities that we've discussed are built into the MetaDefender platform. And the great thing about the platform is that all of these capabilities live within MetaDefender Core, which is the brain of the platform. And then what you can do is you can attach MetaDefender Core to different areas in your environments using our different products to integrate with. So for example, the MetaDefender Core instance itself, it comes with a REST API that quite often we see our customers integrating directly with for file upload and download integrations. We have an ICAP server integration as well. So if you have, for example, existing application infrastructure that is using, maybe it's forward or reverse proxies, load balancers, application delivery controllers, it could be web application firewalls. If they have the ICAP client capability, then there is a very easy way for us to integrate into those existing solutions and offload your file scanning and sanitization requirements to the MetaDefender platform to manage and secure those file uploads and downloads in line as they go through your existing application infrastructure. But the nice thing is also that all of this is deployed as software. And it can be deployed on Windows, Linux, or Kubernetes in containers. It can be deployed online or in offline air-gapped environments. So it doesn't require a direct internet connection for this to work. It can run in completely isolated environments. It can be privately hosted on-premise, or it can be hosted in cloud. We do also have a MetaDefender Cloud instance, which is our SaaS offering, which enables customers to use that quite often for development work. It enables us to do certain integrations with third-party products. I must mention also, we have a great Salesforce integration that enables you to basically have any files uploaded into your Salesforce portals. We can ensure that at the point of upload, those files are scanned and approved before they're made available for download by anyone through the Salesforce platform. So this is both AV scanning, and we can also sanitize the files using CDR as well. So that is a perfect use case where you might have mortgage brokers, maybe it's insurance brokers as well. They could be uploading or requesting pricing information, uploading customer data, KYC data. It could be identity validation, things like that going through your Salesforce platform. That is another ingress point for files to get into your organization. And we can scan those with exactly the same types of capabilities that I've talked you through so far and give you that security around your Salesforce integration as well.
Quick question, Ross. So we're meeting financial organizations every day. You know, some of these are global enterprises, some of the biggest banks in the world. What trend are we seeing? Are we seeing on premises? Are we seeing AWS deployments? Are we seeing more people move to Kubernetes? What works for HubSpot? You know, what's the best deployment model? If we've got customers potentially on the webinar now or looking at HubSpot, you know, where would you be recommending them to deploy? Would it be SaaS? You know, go on, talk through it.
Sure, yeah, absolutely. And I think the easiest way to say it is there is no best recommended route for this. Everyone is using different approaches. Everyone is deploying on hybrid infrastructure. So quite often cloud is being used for development, lab style work, or maybe as a DMZ environment. If you're uploading files into an environment where you want to make sure that they're safe before you actually use them in your secure environment, then the cloud is perfect for that. It's somewhere that you've got a privately hosted application. You can ingest files there. We can secure those files and then potentially make sure they're all safe and maybe sanitized to use as well before you take them back to your on-premise, higher secure environment for longer term processing and retention of customer data. So yeah, the fact is, you know, we can deploy in any of these environments. We do see customers deploying in a complete mix. There really is a hybrid approach here. So this is why we've tried to cover all bases, simply because that's what we're being asked to do by customers across all of these different industries.
Okay, I'm just going to pick a couple of points off the slide, Ross. So just come back to me on these points. You mentioned Salesforce. You know, we're seeing a lot of customers. Well, most organizations, most enterprises are using Salesforce these days. We've won some really big deals on Salesforce. You know, it's a native integration. I guess the news we need to really convey to the audience today is we're now available on the Salesforce App Exchange as well. So we are a very verified partner of Salesforce. So that's really cool. I think the one that's really interesting to me, and I'm in the meetings with you, I know this is really relevant at the moment. I see you've got a storage module on there. Just talk me through the storage module, because it's one that we're getting massive requests for, and we're doing a lot of meetings around MD secure storage.
That's right. So our storage security product is all about connecting the security capabilities you see here to your existing storage. Now, this could be in cloud or it could be on premise. So we can connect to SMB or NFS file shares. It could be AWS S3 storage. It could be Azure Blob storage. The idea being, it's great to deploy Meta Defender and give you that security around your perimeter for files coming into your organization. But what do you do for files that are already within your organization? You've probably got, huge data warehouses with a massive volume of files, backlog sitting there that, there could potentially be latent malware embedded in some of these files waiting to be triggered when someone accesses those files. Now with MDSS, what we have the ability to do is connect those storage file shares to our Meta Defender core instance. And first of all, we can trigger scanning and sanitization on those particular file stores on an event-based basis. So for example, with S3 or Azure, we can subscribe to the messaging queues. We can see when updates or changes or uploads are made into those storage buckets, and that will trigger file scans automatically. But we can also configure periodic scanning. So you could say every 3-6 months, something like that, I want to periodically go through all of my historical data. Obviously, you want to do an initial sweep first, but then go through and constantly look through that data to see, is there potential malware in any of my files already within my security perimeter? And of course, you could scan them today, and maybe that you've received some file with zero-day threat malware in it, and it's been saved to your storage, and it wasn't picked up by the AV engines today. This is absolutely where we would recommend always periodically rescanning as the virus definitions update and as we understand what malware is being released into the wild. It's always best, to periodically rescan your data to make sure that nothing has slipped through and got through those scanning approaches, simply because it's so brand new and potentially targeting your organization.
Okay, thanks, Ross. So, listen, I'm conscious of time, Ross, so I just want to ask you one last question. It's probably really, really pertinent for this audience, for the BFSI audience. So the last 5 deployments we've actually worked on, we're coming across the term AV as a service. They're building out a central cluster of servers. They're allowing other business units to connect into that service. How do you see that model moving forward? Do you think that's the next iteration of what we do in BFSI? We're seeing the movement. So yeah, just get your view on that as well. The shared service model for OpSwap.
It makes sense. What we can do, we often find that different security solutions are deployed based on security requirements and application requirements within businesses. And what we can do here is standardize that approach, because what Meta Defender enables you to do is put a framework in place that enables you to put different AV engines into a solution and potentially add to those AV engines over time. So you've got a capability here where we know we're going to be scanning files. You can change the different AV engines as they release new features, updates, maybe capabilities, maybe they have new AI capabilities as well, to really give you a solid framework for security going forwards. And then because we can configure with the different workflow configurations in Meta Defender Core, you can configure how your services run their files through these different capabilities. So that way you can say, okay, I know I've got maybe software executables or large Windows updates coming in from a particular line of business. I want to run those through a workflow with a pool of servers where they can sit there and it can crunch through these gigabytes of data over time, doing massive archive extraction, looking at all of the file components and making sure that the platform is suited for that type of workload. And then you can have a different pool of servers that would be looking at maybe high volumes of maybe smaller sized files. It could be your customer real-time scan requirements where customers are uploading data and really do want to understand, was my file accepted? I'm sitting here, I'm looking at a web portal. Did they actually receive my insurance claim details or my mortgage application? And this is where you can tailor with a pool of servers that capability and with the different workflows and use a VIP and a front end behind a load balancer to tailor how you route your files through the different options that Meta Defender provides.
And just to that point, Ross, just to make this totally transparent, you don't have to start big with OpSwap. You can start on a particular work case or workload or use case basis. For example, it could be mortgage applications, loan applications, your customer documents. It could be business banking. It could be dash cam footage for insurance claims. You don't have to go all in straight away with OpSwap. Eventually, we'd like to get you where we're deploying a centralized service. But ultimately, let's talk on a use case basis. If you've got budget or you've got a project that's ongoing for a particular use case, I'm sure this technology will fit within that use case boundary. So definitely, if you've got a project out there and you're looking at file upload security, we're happy to work on it per project basis, or we can look at the AV as a service.
Absolutely.
Okay, Ross. So no, we're on to Q&A. I think we probably didn't mention, but we've got a great integration with F5. Some of our biggest deployments over the last year have been as a joint go-to-market with F5 and Nginx. So there's a really, really cool integration with Nginx F5. We're happy to talk about that more after the webinar. If you want to get in touch with Ross, email address is on the screen. But I'm hoping you guys are ready for some Q&A. Stick the questions in the chat box now, and we'll get answering those questions for you. Okay, guys, if you can see on screen now, we've got some reports for file upload security. We've got some white papers, some case studies. Please visit the OpsWhat website. You can download those and read those at your own leisure. But yeah, please post some questions in the chat box, and we can quite happily run through any questions you might have. We already see a couple of questions popped up there, Ross, so we can take those in the next second or so.
Sure.
So first question I've got, which I guess this one was coming, is about price. What does OpsWhat cost? We can't give a figure out of the air. There's so many variables when we price OpsWhat. It can be the amount of files, the type of files, embedded objects, the size of the files, how many AVs are you running? Could it be 16? Could it be 20? Could it be 30? So there's lots of variables to actually pricing OpsWhat. The best thing to do if you have a project is send some sample data sets. Once Ross and I have met with you, just to run through the platform again. But yeah, it's very difficult to size. One size doesn't fit all. If you look at the SaaS model is slightly different. We can give you pricing on that. We price that per API call, sorry. So every time you scan a file is an API call. Every time you run a file through our CDI is an API call. So we sell those in buckets of 5, and that's also the same pricing model for Salesforce as well. So cloud per API. If you're looking for an on-premises or a public cloud deployment, we'd have to get some data sets to actually run through those pricing and sizings for you.
Great, there we go. The question, can you integrate with other SOC tools like Splunk, or do we have to use your web UI to investigate security events? Absolutely, yes, yeah. So we're very aware that we need to fit in with your standardized security operations procedures within your environment. So yes, absolutely. Anything to do with file scan, audit data, even down to sort of the performance of the engines, things like that. We will collect all of that information. We can export it in syslog format. So that can be sent through to, it could be Splunk, it could be Azure Sentinel, something like that, as well as also anything to do with changes made to the platform itself. So things like configuration changes, people making user changes, permissions changes, any changes to the workflows as well. All of that audit log can be exported in a syslog format. So you've got a full sort of compliance and regulatory tracking going on in terms of what's going on with the platform. So, yes.
Okay, I can't see any more questions in the chat box. Ross, do you want to just flip to the final slide? Okay, guys, well, thank you for joining the webinar today. We appreciate taking 30 minutes out of your busy working day. I hope you enjoyed the session. If you need any follow-up or any further clarification on what we do, how we do it, we're more than happy to set up a follow-up call. You can reach out to the webinar link, or you can reach out direct to Russ or myself. But please see the QR code on the screen that will take you to the OpsWhat LinkedIn page. By all means, visit opswhat.com for more information. But thank you for your time today. Really appreciate you taking the time to join. Thank you.